Welcome to Math 201, first lesson of the semester. We're going to talk about section 1.1 and 1.2 from your textbook. Let's start by discussing what is a function. You may remember there's a formal definition of a function. It says that given any input, which is usually an x, a function gives exactly one output, which we usually call y. We tend to express or represent a function via a graph or a table of values or an expression with variables in it. So here I have a function. Each pound of apples costs $2. That's a description of a relationship between two variables. Um, and we can represent this function with an equation or a graph or a table. So let's start with an equation where we let x be pounds of apples and y be cost in dollars. Okay, so my equation would be that the cost, y, is $2 for every pound, so 2 times x. So it's one way of representing that relationship, that functional relationship between number of pounds and the cost of the apples. We could draw a graph of this situation. We know that, say, 5 pounds of apples would cost $10, 0 pounds would cost $0, and this is a line like that. Or we could make a table of values for x and y. We know that 0 pounds of apples cost $0, 1 pound costs $2, 2 pounds, $4, 5 pounds, $10, etc. What are some types of functions that we know? So some functions that you should have some familiarity with coming into a Calculus 1 course would definitely be linear, quadratic, exponential, logarithmic, trigonometric, polynomial, and rational. That's sort of the key core types of functions that you should have some familiarity with coming into this course. Today, we're going to be reviewing linear and exponential functions. And some of the other types we will review as the course goes along. Instead of doing all the review at the beginning, we're just going to review sort of as needed right before we need it. So linear functions. There are two very commonly used formulas. There's a third, but it's almost never used. But we have y equals mx plus b, which is the most familiar for most people. M is slope, and b is the y-intercept. And we call this slope-intercept form because it uses the slope and the y-intercept. Okay, and then we have another one called point slope form, and it's y minus y naught equals m times x minus x naught. And in this case, x naught, y naught is any point on the line, and m is the slope. And we call this point slope form. So linear functions should be quite familiar to you. You've probably studied them in several math classes before. We will do a little activity later to refresh your memory on how to use these formulas. Okay, next we're going to talk about exponential functions. There are two possible formulas for an exponential function. This is probably a little bit newer to you than linear. Hopefully you have seen this before, but you may have only seen it in one previous math class, not several. So it may be less familiar than um, linear functions. So there are two possible formulas, f of x equals a times b to the x, or f of x equals a times e to the kx. So these are called exponential functions because the variable x appears in the exponent. So exponent is the root word of exponential. Um, so the variable x appears in the exponent. That's what makes it an exponential function. In both of these forms, a is called the initial value or the y-intercept. Okay. And the value of b in that first form is called either the base or the growth factor. Factor, because factor is the word that you use to describe one of the numbers in a multiplication problem. And when you're raising a value to an exponent, that means repeated multiplication. That's what exponents are, repeated multiplication. So this b is a factor. It's something that you're multiplying by over and over and over again. So we call it a growth factor. Okay, it can also be called a decay factor if you're multiplying by a number smaller than 1. Things are getting smaller. Okay, and then the value of k in this other format is called the continuous growth rate. Okay, so if you are working on a problem that mentions a continuous growth rate, that should be a big hint to use this formula rather than this one. Okay, our activity for this lesson is called Green Roofs. I would like you to work on this activity on your own without watching this video. Try to do as much of this as you can. So I'm going to suggest you pause the video now, work through this activity, and then if you need to, come back and check your work, or you got stuck and you don't know where to go, come back and watch the rest of this video. Okay, activity, green roofs. Recently, large office buildings have been turning their flat roof space into green roofs covered in plant life to compensate for their large carbon footprint. As the city planner in Normal City, you are spearheading a grant program to give local office buildings funds to convert their roof space into a green roof. You have the following data. So if we measure months since the grant program began, we have data from 0 when the grant program began to 4 months after the grant program began. And at the beginning of the grant program, there were 600 square feet of green roof, and 4 months later, there are 1,800 square feet of green roof. If you assume that the square footage is growing linearly in time, okay, so they're telling us what kind of function to use. Write an equation L of t for the square footage of green roof space as a function of months t. Okay, so I have two options. I can use y equals mx plus b, or I can use y minus y naught equals m times x minus x naught. In either case, the first thing I need to do is calculate the slope. I have 2 points here. This is x1, y1, x2, y2. So I'm going to calculate the slope by doing change in y over change in x. So my slope, change in y over change in x. So I subtract the y's, 1,800 minus 600, over subtract the x's, 4 minus 0. So that's 1,200 over 4 would be 300. So I've got my slope, and then I have points, but I also have the y-intercept. 0, 600 is the y-intercept because the definition of the y-intercept is when x is 0. Okay, when x is 0, you're on the y-axis. So this is my y-intercept b. So I could use y equals mx plus b. I have y equals 300x plus b, which is 600. Oh, and I'm supposed to name it L of x. Let's rename that. I could also have used point slope, where I have y minus y naught, y minus, maybe I'll use the other point, 1800, equals the slope, 300, times x minus x naught, which is 4. And then if I solve for y, I'm going to get y equals 300x minus 1200 plus 1800 is plus 600. And we're going to rename that L of x. So you see, you get the same thing, whichever whichever method you choose. Now we're going to assume that the square footage is growing exponentially in time and write an equation for the square footage of green roof space. Okay, so I'm going to use E of t equals a times b to the t. And a, they told us earlier, is the initial value or the y-intercept. So I know the y-intercept is 600. So I'm going to make that my a value. So this is going to be 600 times b to the t. And I just have to figure out what b is. I'm going to use my other point to figure out what b is. I'm going to say, well, if I plug a 4 into this equation, so e of 4, that would be 600 times b to the 4th. That's supposed to give me 1800. Okay, because I know that when t is 4, square footage is 1800. And now I can try to solve this equation for b. Okay, so I have b to the 4th equals 300. So b is going to be the 4th root of, oh, sorry, 1800 divided by 600 is 3, not 300. So b is going to be the 4th root of 3. Okay, so then I'm just going to go back over to here. And now I know b. So E of t is going to be 600 times the 4th root of 3 to the t. Now, the 4th root of 3 is always also the same thing as 3 to the 1/4. So I could rewrite this as 600 times 3 to the 1/4 t, or 600 times 3 to the t over 4. Any of those is an acceptable answer. All right, on the axes below, sketch a rough graph of the functions L of t and E of t. Okay, so they both go through the point 0, 600 and the point 4, 1800. And the linear function connects them with a straight line. Try that again, like that. But the exponential function is going to be concave up. So it's going to look more like this. Okay, so which function is larger when t is greater than 4? So here's t equals 4, and the exponential function is now larger. So that is E of t. When do each of the models predict that there will be 2,400 square feet of green roofs? Okay, so what I'm going to do is I'm going to set each of these functions equal to 2,400 and solve for t, because the question is when, so we're going to be solving for time t. So I have 2,400 equals 600 plus 300t, and I'm going to solve for time. So 2,400 minus 600 is 1,800 equals 300t. And divide by both sides by 300, and we get t is 6. So 6 months. Okay, but the exponential function, how long will that take? So I'm going to make E of t equal to 2,400 and solve for t. 600 times 3 to the t over 4. Okay, so first I'm going to divide both sides by 600. So 2400 divided by 600 is 4. So I get 4 equals 3 to the t over 4. And then I have to remember how to solve an exponential equation. So you might remember from a previous course that when you have a variable in the exponent or the unknown in the exponent, to get it down, you take the log of both sides. So I have the ln of 4 equals the ln of 3 to the t over 4. And the reason we take the log of both sides is because there's a property of logs that allows us to take that exponent and bring it down in front of the log. So now I have the ln of 4 is equal to t over 4 times the ln of 3. And then I just have to get t by itself. So I am going to divide both sides by ln 3. So I have t over 4 equals ln 4 over ln 3, and then multiply both sides by 4. So I get t is 4 times ln 4 over ln 3, which I should put in a calculator to find out what this is approximately. So my calculator says that this is approximately 5. So 5 months. This answer, 4 ln 4 over 3, is called an exact value. This answer is called an approximate value. So just pay attention to how your homework wants the answer or how a test question wants the answer. It will specify give an exact value, which means leave the ln's in the answer, or give an approximate value, which means put it in a calculator and get an approximate value.